Hello everyone, this is KP the Math G, and I must say it's a beautiful Sunday and a beautiful day to talk about calculus. Well, any time you're inside, no matter what the weather is, it's a nice day to talk about calculus, isn't it? Well, I'll tell you before we start here, man, I ate good. And I tell you what, I have a tendency at buffets to go back for seconds, and I did, and I'm paying the price for it. It's good food, but I am going to try to stop getting seconds from now on, I tell you. Or if I get seconds, I'm going to get a very small portion. Oh, well, anyway, the food was good. That's all I'm going to say. Alright, let's talk about this. This is the 2024 free response question number 6. And we've already done parts A and B. Now we're going to do part C in this lesson. Part C says write an integral expression that gives the volume of the solid. That's a region S. Alright, when rotated or revolved, if you want, whatever you want to say, rotated or revolved about the horizontal line y equals 20. Alright, so we got to determine if this is a volume of, if this is a solid of revolution, or is this a kind of like a washer method where you have a hole in the center. So when you think about it, you have an open space right here. Here's your S up to here, isn't it? Alright? Okay, so what I'm going to do is we got to revolve this whole region, starting from here. We're going to revolve this region about this line here. So let's see if we can do that. I'm going to have to just throw away some pens and buy me some new ones. Alright, here it is, right here. Alright. So it's going to be revolved, and I've got a little iso interval. It's going to be revolved about this line right here. Now, if you can picture this going around this way, and certainly if you see an open area like this, this is definitely going to be a washer method. Okay, if you can kind of picture this kind of coming over this way like this and being revolved, you know, I can't go too far up because of my board is just kind of small, but it's going to leave a hollow circle right here. You know, see what I'm saying? You're going to have a circular area right in here. Alright, like that. That's going to leave a circular region here. So, yeah, it is. Alright, and that's why you are dealing with pi r squared, because that is your circle, and it's the area times the thickness of that, delta x dx, and that's going to give you the volume of revolution. That's how that works. Okay, you have to realize this is a hole. Now if this were revolved about the x-axis, you would have something coming down like this. Alright, kind of like that, and you know that that's solid through and through, and when it comes around it's going to be solid here, down here too, right? It's going to come down here solid, leaving no holes. So you would just have one radius squared to worry about. But what we got to do here is, since we do have a hole, so you got to answer the question, do we have a hole? Well, yes, we have a hole. Alright, and I'm going to get a different color because that black is not turning out too well at all. But we do have a hole, so that means that we're going to go from one to another. This is pi on the outside, and then we have r squared, and we know that we're going from 2 to 5. Alright, and so you automatically get this form every single time. You got a big R, big radius squared. I know that you've probably seen this before. Alright, and then you have what you call delta x. Alright, so big radius squared minus little radius squared times delta x. Pi r squared, big radius squared minus little radius squared, delta x. But now let's at least get it set up here. For lack of room, I'm going to just go ahead and erase this, and we're going to try our best to fill this in. Okay? Alright, so we know that it's going to be pi. I'm going to squeeze this over here. Alright, now we are going from 2 to 5. So that's all we're asking to do is set up, right, but do not solve, an integral expression that gives the volume of solid. Okay, so this is going about this line. Alright, right here. You have a radius here. Alright, so you got what you have here, okay, guys and girls and ladies and gentlemen, is that you have a hole, so you know it's going to be r squared. I'll put this back up here. Okay, in this case, r squared minus a little r squared dx. Now, what the big R is, it's everything from the bottom all the way to this number here. That's your big R, that's your radius, that's the whole thing. Now what we want to do is we want to subtract off this whole right here. That's going to be your little r. So you don't want to just have a big R and not subtract off that whole. Alright, that's what you want to do when you're dealing with this type of problem. You got a big R minus your little r. Well, your big R, how tall is it? Obviously, you can see how tall it is from here to here. This is big R right here. Okay? Well, obviously from 0 to 20. So we're taking big R to be 20 squared. Okay? Now I want the minus sign. Now I want the little r, which is really now, let's just go right here. Right there. I want that right there. Well, now, that may be the most difficult thing that calculus students in general have problems with. Big R is easy. That's 20. Alright? What is the height of this? Well, I want to know what the height, let me erase the S and put it over here. I want to know what this height is. So that really and truly, if I can subtract off this part right here, if I know how much to subtract here, I've got this remaining left that I want, see? Alright, I want to take away this part, this radius. I want to know how long this radius right here is. I want to know how long. This is my whole squared right here. That's really what little r is. Okay? So I want to figure out how much radius this is. Well, how tall is this? Well, somebody say, well, Kp to the math g, that's y. That height is y because this touches this function y. Well, what is y? Well, y happens to be, I'm going to erase this x altogether. This is x squared, that's g at x, which is x squared minus 2x. This is little r, not little r, but this height here is this, alright? This whole thing is 20, so if I can take away this y, so 20 minus y, right? 20 minus y squared, all right, but then dx, right? All right, 20 minus, well, what is y? Well, it is x squared minus, it's this whole thing minus this. There's your whole. So this is your whole. This is your whole right here. How much, this radius represents your whole. That's what I want to subtract off. I want to subtract off that whole. So I can really have this, is what I'm trying to say. So if I can take this away, I'll know how much I have left for my whole, right? Alright? So if a stick is 5 inches long, I take off 2 inches, I got 3 inches left. That's how much I had, that's how much whole I got left, see? Alright, so I got to take this away. So I'm taking this part right here. So 20, this part here then is 20. This is x squared minus 2x. This whole thing minus this is this, isn't it? See that? The whole thing is 20 minus this is this. So really this is 20 minus y, whatever that is. But y, we know what y is. Okay? So really and truly, if I can find some room for this. Alright, so we're going to have this in just a moment. Pi from 2 to 5. We might just have to turn this thing over. Well, anyway, this is 20 minus, now 20, well, let me get over here, minus, okay, now y, which is, you might want to put that in parentheses that you have more than one term, x squared minus 2x, close parentheses. Now close this parentheses, and then close this. We'll just make this a bracket. And actually we do need to square this, and we need to square all of this, and then close it, and then slide a dx right there. There's your thickness right there. Remember, that is your thickness, and that's it. Now do not do any more. Don't distribute the negative sign. You can't do that anyway. You got to square all this anyway. Don't do any more. You've got it. Okay? So from 2 to 5, x squared minus 2x. Okay, so here's what it's going to be like. I'm going to go ahead and put it right here in big, make it look big. So this is pi from 2 to 5. So 20 squared, okay, minus, all right, now 20 minus x squared minus 2x, close that parenthesis. Don't square it here. You're squaring all of this. Now you got to remember, you got to square all of that. Don't just square it. Don't do this kind of nonsense here. You've gone too far to mess up now. Don't square just that. You didn't square your 20 here. So to get this, you've got to get it all squared, you've got to match these two parentheses here. Now you can square all of that, see? And then you've got this bracket over here. So bracket here. Now you got everything done. This squared minus this squared. Now dx right there. Okay. So many students want to square right here when they forgot to square the 20. You can't do that either. You can't just square that and square that. You got to square the whole thing. It's like a minus b, the whole thing squared. Okay? So that is all you have to do to that. You don't have to solve it. You don't have to do anything to that. Although it can be solved, we're not going to solve it. It's probably going to take a lot of work to do it manually. Okay, and this is done without a computer, a calculator anyway. So this is what we're talking about here. So this is the part you got to kind of pay attention to. So it's the whole thing. All right, pi a to b the whole thing squared, the whole thing, all of it, minus the whole. Alright, squared, and then whatever. Okay, if this case is dx, then delta whatever, and there you go. Okay, in this case it's dx, so I'm just using dx right there. Alright, and that's what we did. Think about this, and just think, you got it. If you use 20 over here, use 20 over here. So 20 squared, the whole thing, minus this part here, and that's what they want you to get here. That y happens to be this, so minus all that squared dx. Okay, and that's really all I need to show you there. Okay, let's do a real quick, since this lesson took very little time to do, let's change this up just slightly. Alright, okay, and let's revolve this now about the line y equals 0. About, oh my goodness, I crowded it. About y equals 0, which is just the x-axis. Alright, I'm going to revolve this about the x-axis. Well, I don't have a big R minus a little r anymore, do I? I just have this radius here. So pi times r squared. So pi, still from 2 to 5, from 2 to 5. Put your isolated interval anywhere you want to. Thickness, any thickness you want to. Now pi times x squared minus 2x squared. Don't forget that. And then to make it complete, dx. Okay, if you set that up without solving, then that's what you would do if you were revolving about. So this is a case where you do not have a hole, right? You see what I'm talking about? Okay, that is what we're dealing with here. Now, one more thing here. Let's do this one more time. Instead of about the x-axis, let's go with y equals -1. And I'm going to try to be brief here. Y equals, we're through with the lesson. So if you want to get off, you're welcome to get off. But I just want to show you. So y equals -1 is here, down here somewhere. So I'm just going to do a little real quick thing. Here's -1. I know I'm not going far enough down, but here we go. This is a hole, isn't it? See? This part here is, look at this right here. Here's your solid part. You don't have solid through and through. You got this hole right here. So again, it's the whole thing, the whole radius, which is, now don't subtract 1 even though you're going down to -1. You got 1, you're counting units. How far is this? It is this y plus 1. See, this y plus 1 more will give you this radius. So you got 1 unit right here, and then you got this y here. The rest of this is y. So it's this whole thing is y plus 1. Okay, so you're still going from, let's put the pi here, from 2 to 5. And then you're going y plus 1, y plus 1 squared minus sign, and then you still just got this whole is only 1, so minus 1 squared, and then dx. Alright, the y though is x squared minus 2x, so we would just do that. Pi from 2 to 5. Alright, so let's see, x squared minus 2x, that's your y right there. Okay, your y is that, plus 1, okay, and then you're squaring that, and then there's your plus 1 right there, and then minus 1 squared, and then of course, let's see, it's this part minus this part, and then delta x. So there it is. You're still going to subtract off 1 right here. You're adding 1 because of this entire length here with a y plus that 1 here. Okay, there's your y. That's your y right there. X squared minus 2x. Okay, that's this y here, and then adding 1 to that y, and then minus, always subtracting off the whole. You only have one unit as the whole, and that would be it right there. So that is what you do there. Just kind of giving you different scenarios here very quickly as what, since this was not a very long lesson anyway, just kind of giving you some scenarios here that you need to look at. And if you get this down, you have got it. The only other thing we have is rotating something around some x equals something, then you got to solve for x, Okay. All right. So anyway, this is KP, the Math G, getting ready to sign off. Please make a comment if you'd like to. Hit that subscribe button if you'd like to, and then of course hit that like button. I just wanted to pick this one out. I'm going to come back to 2022 on the next video. This is going to make my 156th video right here. So my 157th is going to go back to 2022, and we're going to answer question number 1 next time. This is KP, the Math G, signing off. Again, this is for you and not for me, but hit that subscribe button and make a comment if you'd like to, and hit that like button. Put a smile on my face every time. KP, the Math G, signing off. Ladies and gentlemen, have a great day.